Thank you for inviting me to speak today. My name is Bill Easterling, and I'm the Assistant Director of the Geosciences Directorate at the U.S. National Science Foundation, or NSF. The National Science Foundation is an independent federal agency created in 1950 to promote the progress of science, to advance the national health, prosperity, and welfare, and to secure the national defense. We fund people, infrastructure, and innovation to advance knowledge to new frontiers and increasingly to action. The Geosciences Directorate supports basic research that advances the frontiers of knowledge and drives technological innovation while improving our understanding of the many processes that affect the global environment. Geo research spans the atmospheric, earth, ocean, and polar sciences. NSF has been a global leader in basic ocean science since its establishment. 4 of NSF's first 100 awards were ocean science related. And I'm thrilled that today's workshop is serving as a capstone for such an important conversation to explore the applications of open, freely available data from the global biogeochemical Argo float array to a whole suite of possible uses, from climate and environmental forecasting to fisheries to accelerating the blue economy. This past year, NSF announced a $53 million investment to significantly expand our global fleet of robotic floats, transforming how we observe the ocean. The Global Ocean Biogeochemistry Array, or GO-BGC array, will ultimately contribute an additional 500 robotic floats to collect chemistry and biology data from the surface down to a depth of more than a mile. Within GO-BGC, 5 research institutions are working with industry partners to construct the floats as part of NSF's mid-scale research infrastructure 2 program. The U.S. contribution to the global network builds off the successes of previous NSF contributions, most notably the Southern Ocean Carbon and Climate Observations and Modeling Project, or SOCCM. SOCCM has been a game changer for understanding the Earth's Southern Ocean, and GO-BGC expands the U.S. contribution to the world's ocean. As with SOCCM, the GO-BGC aim is to drive a momentous shift in our ability to observe and predict at the global scale the effects of climate change on ocean metabolism, carbon uptake, and living marine resource management. Researchers, educators, and decision makers worldwide have free access to the collected data in near real time. In March and April of this year, GO-BGC's first floats were deployed in the Western North Atlantic through a partnership with the International Global Ocean Ship-Based Hydrographic Investigation Program, or GO-SHIP. 12 biogeochemical floats were deployed by researchers and crew of the research vessel Thomas G. Thompson. And you can follow the expeditions and see the status of the floats on the program website, gobgc.org. The GO-BGC Array NSF Award also supports an outreach program that aims to diversify the blue workforce through undergraduate, graduate, and postdoctoral programs. And it includes scientific training workshops and building curricula with educators. An inclusive STEM literate blue workforce is prepared for the future, and that is fundamental to ocean innovation. This is particularly true when considering the acute impact of COVID-19 on the blue workforce, especially for graduate students and early career scientists. We recognize that technology can enable inclusion. NSF-funded programs such as the GO-BGC array make data freely available, overcoming major technological barriers to the broad inclusion of diverse perspectives in the ocean sciences. If we are to truly overcome society's greatest challenges, we will need the best and the brightest from across the globe to work on these problems. At NSF, we seek to recruit, retain, and develop diverse and high-performing workforces that draw from all segments of society, and values of fairness, diversity, and inclusion are used in promoting the progress of science. Programs like GO-BGC, which further these goals, brings us closer to achieving the ocean research and education ecosystem's full potential. I'm thankful to the workshop organizers, to my colleagues at NASA, NOAA, and the State Department, and to the G7 Future of the Seas and Oceans Initiative for inspiring and convening the important conversations which have taken place over the last few weeks. I'm inspired by the international collaboration evident here at this workshop to promote the important role that ocean science infrastructure has on our research ecosystem, but also for other great societal benefits. I applaud the sentiment of knowledge to action, that by bringing together diverse perspectives and uses, we can apply the knowledge gained through investments such as NSF's GO-BGC array to enhance implementation, and that the best available science is used to make informed decisions, inspire innovation, and further drive our understanding of the geosciences. It will take continued collaborative approaches to support the research community in overcoming the coronavirus pandemic's impact and tackling our shared climate crisis. Through leveraging global partnerships in our ocean research and education enterprise, and in bridging the gap between science producers and science users, together we can embrace the frontiers of knowledge while stimulating the ocean economy. Thank you, and I look forward to hearing the outcomes of this workshop.